Good afternoon. This is the iodine clock reaction presentation, and my name is Cheyenne Smeaton. The materials I needed for this experiment was hydrogen peroxide, vitamin C, cornstarch, and iodine. Those were the materials that was listed on the course assignment. However, after further listening to the video that was instructed for us to watch, I also needed coffee filters and a heat source. And we'll talk about that in a little bit on the later slides as to why I needed those things. This experiment needed both two solutions, solution A and solution B. For solution A, I had to mix vitamin C in the iodine tincture. I needed 4 500 milligram vitamin Cs and 60 mLs of the iodine tincture. For solution B, I needed 0.4 grams of cornstarch and 150 mLs of hydrogen peroxide. So for the first steps for solution A, I needed to crush the tablets of vitamin C into a fine powder. Once I crushed them into a fine powder, I had to pour 60 mLs of water on top of the crushed tablets and stir for 30 seconds. Now, since the vitamin C was crushed, it was able to absorb the water faster. And after I stirred it for 30 seconds, there was still remnants that was undissolvable, which is why in the next step for solution A, I needed to pour the solution on top of coffee filters that sits upon a container. In my example, I just used a clear plastic cup, and this will ensure that we separate undissolved material from the liquid. While we are waiting for solution A to filter, because that can take some time, we will then create solution B. Here's a couple pictures from the experiments I did at home. You can see that I had 2 clear cups, both labeled, one solution A and the other solution B. In the middle picture, you'll see the crushed up vitamin C. The vitamin C that I had was the color orange, so it doesn't really play into a factor of the experiment, however, you will see the orange color. On the third picture, you can see that I added 60 mLs of water to the crushed up tablets. Solution A is on the left. You can see that I poured it into the coffee filter and it started to filter. At the bottom of the cup, you can see a little splash of the solution filtering through. And solution B is on the right. This is after I created it and after I boiled the water. This is where that picture had come from. So I had already added the cornstarch to the water and I did boil that, and this is the picture. The experiment continued. For step 2, for solution B, like I said, I did take a picture after this. However, I will discuss what steps needed to be taken in order to fulfill that process. First, I needed to measure out the 0.4 grams of cornstarch into the container, and then I poured 350 mLs of water on top of the cornstarch, and I mixed it for 30 seconds. Because the solution was really cloudy, we wanted to boil it. Once it was boiled, we had to finish filtering it with the coffee filters because it was still a little cloudy, meaning there was still too much cornstarch remaining in the solution. Once it was filtered, we added 150 mLs of hydrogen peroxide. Once added to the solution, we then mixed it. Here is 3 pictures of what I was doing during this process. So you can see in the first picture, that is me pouring the boiled solution of cornstarch into the coffee filter. And then in the second picture, you can see that I am pouring the iodine into the vitamin C solution, which in the next slide I will show you the steps for that as to what we needed to take. And in the third, you can see that I'm pouring it into the cup, and what that really was representing, because I could not upload a video, for some reason it was not working. However, what that's representing is that the iodine is remaining the same color as the vitamin C. So In the video that we watched for the instructions, we could tell that the iodine turned back to a clear substance, and in this solution, like I talked about before, my vitamin C solution was orange due to the color of the tablets. So in this solution, the iodine turned orange because that is what the vitamin C color was. Solution A and the last step. Now, once the solution is filtered, we must mix the iodine with the leftover vitamin C solution, which in the previous slide you just saw. When the iodine is added to the mixture, it does lose its color. The reason why is because the iodine serves as a reducing agent and reduces iodine to iodine ions. The last step is that we mix equal parts of both solution A and solution B into one carrier. We wanted to make sure that there is equal parts because both solutions have important ingredients that need to be mixed. Once the solutions are in one container, we can mix them. Once the solution is mixed, depending on the temperature of the solution, it will turn to a blue-black color. So the temperature will depend on the rate of that blue-black color change. So a higher temperature will create a faster effect, whereas a lower temperature will create a longer effect. These are 4 pictures that I wanted to add to the slide because, as you can see, in the first picture, yes, that's the iodine being added. In the second picture, that's the iodine staying the same color. In the third picture, that is me pouring the vitamin C solution into solution B. So once solution A and solution B is together, I then wanted to mix it, and you can see the blue-black color that resides in the bowl. As soon as I started to mix the solutions is when it turned to a blue-black color. The explanation is, why does the solution turn to a blue-black color? Well, the hydrogen peroxide consumes the vitamin C. When the hydrogen peroxide is added, the vitamin C not dissolves, but just is limited, and the iodine starts to accumulate because there is less vitamin C. Very quickly, triiodide complex is formed and will quickly form to the starch. That triiodide complex is what is residing afterwards. The solution that is left is a blue-black complex of the triiodide and starch. The concentration of each reactant and the temperature of the reaction mixture will determine how long it takes for the color to change. And here's my work cited. You can see that there is 4 sources, and I hope that everybody enjoyed my presentation and learned a little bit about the iodine clocks. Thank you, and have a great day.